Yeah, we're in section 3-5, and what we're going to do is figure out how to solve differential equations that are linear and that have a forcing function. So that means they are not homogeneous. So I have something that looks like that. And we have two methods to do it. The first method is called undetermined coefficients. Maybe I spelled that right. Who knows? And what we're going to do is we still have to solve for the homogeneous solution. And our y sub p is going to be, and our y sub p is going to look like this. I'm going to do something before we start. We're going to get rid of this a, b, and c and change it to something else. We're going to call it P1x and P2x. How's that? Because I don't want you to be confused. Okay, so y sub p is going to be a f of x. That's a plus sign, in case anybody was wondering, plus b f prime of x. And we're taking all the derivatives of f of x is what we're doing. C f double prime of x all the way out to, we'll call it n, f n of x, if that makes any sense. So depending on what f of x is will determine what we're going to do. So if my f of x is x squared plus 1, then my y sub p would be a plus bx plus cx squared. Unless there was something else going on that we don't know about, and we'll get to that when we do. And if my forcing function was sine x, then my y sub p would look like a cosine x plus b sine x, and I would have to solve for my a, b's by c's, and that's how I'm going to get the coefficients to be undetermined. Now, the second way that it happens is a theorem that's on page, let's see if I can find the right page number here. Page 194. 194. And it's called variation of parameters. And you have a function that's y double prime plus, we'll call it p of x, y prime plus q of x is equal to 0. We have a function that looks like that. No, f of x, because this is going to get you your particular solution. And what you're going to end up doing is solving the homogeneous equation. So we've got to solve that first and come up with y1 and y2 in this case. This is only going to work for a second order type guy. And then you're going to find the Wronskian of y1 and y2. And then you're going to say y sub p is equal to minus y1x, the integral of y2x plus the times the forcing function divided by the Wronskian of y1, y2, plus y2 of x integral y1 of x the forcing function divided by the Wronskian. Now, after you have found y sub p, that doesn't necessarily mean that you're home free. You still have other things you're going to have to consider. And your final solution is still going to have to, final answer of the problem, unless all it asks for is the particular solution, is going to be y sub c plus y sub p again. Okay, so those are the things that are there, but there are some tricky things involved too, which is always the case when you do math things. Alright, so it's time to work some problems. We'll look at number 2. Number 2. Y double prime minus y prime minus 2y is 3x plus 4. 3x plus 4. Get to the right page of the book. Make sure that's the right problem. Yes, it is. And what are we supposed to do? Find the particular solution of these equations, and all these problems prime indicates derivatives. Okay, so all we're looking for is y sub p. Alright, so y sub p is going to be, well, first of all, we're going to have to come up with the characteristic equation, and I'll explain why after I solve it. Minus r minus 2 is 0, and that's going to factor r minus 2, r plus 1 is 0, so my r is going to be minus 1, 2, and my homogeneous solution c1 e to the minus x plus c2 e to the 2x. Now, the reason I did that is because if any of these guys exist in the forcing function, then I'm going to have to do something different than what I'm doing. And they don't, so everything is fine. And my y sub p is going to be a plus bx. And that's all it's going to be. Except I want to know what a and b are. Isn't that cool? So I'm going to go y prime of p is b, and y double prime of p is 0. And I want a 3x plus 4 on this side, and I want minus 2 of them, minus 1 of them, and 0 of that guy. 0 times 0 is 0. Isn't that cool? So I have minus 2a minus 2bx minus b. Okay, so that's what I've got. I look at the unit term and I see that 4 has to equal minus 2a minus b. And I see that 3x has to equal minus 2bx. So from that, I will conjure up that b is going to be minus 3 over 2. And if b is minus 3 over 2, 4 is equal to 2a minus minus 3 over 2, then I'm going to say that a is equal to minus 5 over 4. Okay? So, and then I can and then I'll write down my final answer. Final answer. Y of p is equal to minus 5 over 4 minus 3 over 2x. I think it's a good idea to check our work. So if y sub p is minus 5 over 4 minus 3 over 2x, and y prime of p is minus 3 over 2, and y double prime p is 0, and I want one of these guys and minus one of those guys and minus 2 of these guys, and I'm supposed to have 3x plus 4 when I get done. Okay, so I got 5 halves and 3 halves is 8 halves, which is a 4. And then I've got a plus 3x, so my that solution checks. Okay. We're now going to go on to talk about something else. So, if I have a hyperbolic sine of x, what does that mean? That means I have e to the x minus e to the minus x over 2. If I have the hyperbolic cosine of x, what does that mean? I have e to the x plus e to the minus x over 2. If I take the derivative of the hyperbolic sine, what do I get? I get the hyperbolic cosine. And if I take the derivative of the hyperbolic cosine, what do I get? Well, I get the hyperbolic sine. Okay, so these are cool functions. So if I were to have a characteristic equation that ends up giving me r's that are plus or minus 1, you'd say, well, the solution y is equal to c1 e to the x plus c2 e to the minus x works. But you have another solution that says c1 hyperbolic cosine x plus c2 hyperbolic sine x. And both of those solutions check. And so you could, I left out the one. You could be using hyperbolic sines, hyperbolic cosines when your characteristic equations give you r's that are the same. So if I had an r that was plus or minus 10, then y could be c1 hyperbolic cosine of 10x plus c2 hyperbolic sine 10x, and there's nothing wrong with that solution. It's perfectly okay, along with the one that would be c1 e to the 10x plus c2 e to the minus 10x. Okay, just one of those things we'll throw in there, and hyperbolic sines and cosines will come back and haunt us at a later time. Don't worry about it. Worry about it, but don't that much. Oh, wait, they're here already. Y double prime minus 4y is equal to the hyperbolic cosine of 2x. All right, so we're going to look at the characteristic equation for the homogeneous equation, and I have r minus 4, r squared minus 4 is 0, and that factors r plus 2, r minus 2 is 0, so r is going to be plus or minus 2. Very interesting, isn't it? R is going to be plus or minus 2. So now, if I use, I could say that y is equal to c1 e to the 2x plus c2 e to the minus 2x. Or I could say that y is equal to c1 hyperbolic cosine 2x plus c2 hyperbolic sine of 2x. In either event, I would have to go and come up with a characteristic equation. So if we keep it in hyperbolic sine and cosine, then what we'd end up doing, because the equation itself has that term in it, we're going to have to throw in an x guy. So y sub p is going to be a x hyperbolic sine 2x plus b x hyperbolic sine 2x. Okay, and y prime of p I'm going to have a hyperbolic cosine 2x plus 2a hyperbolic sine 2x plus b hyperbolic sine 2x plus 2bx hyperbolic cosine 2x. And I left an x out there, didn't I? 2x a sine. And then y double prime p is going to be, and I get 8 terms this time, so that's cool. So I've got 2a hyperbolic sine 2x plus 2a hyperbolic sine 2x plus 4x hyperbolic sine hyperbolic cosine 2x hyperbolic cosine of 2x. And now we're working on this guy, plus 2b hyperbolic sine 2x plus 2b hyperbolic cosine 2x plus 4bx hyperbolic sine 2x. Now, isn't that just lovely? That is just so marvelous. Okay, now we want one of those guys minus 4 of these guys, and we don't want any of them at all. And when we get done, we want it to be the hyperbolic cosine of 2x. Hyperbolic cosine of 2x. That's all we want to see. Okay, well, here I've got minus 4ax. And down here I have what happened to my a. Okay, that's my a. So I got minus 4ax hyperbolic cosine. I got 4 plus 4ax hyperbolic cosine. They go away. Here I have minus 4bx hyperbolic sine. Minus 4bx hyperbolic sine. That goes away. That goes away. Okay, well then all I've got left is 4a hyperbolic sine 2x plus 4b hyperbolic cosine 2x. Alright, well that seems good. Obviously a can be 0 and b can be 1 over 4. And my particular solution that I'm looking for is going to be 1 over 4x hyperbolic sine 2x. Final answer. Okay. Do I need to check it? No, I basically, well, maybe I do. I don't know. Why don't we check it? Y particular 1 over 4x hyperbolic sine 2x. Y prime 1 over 4 hyperbolic sine plus 1 over 2x hyperbolic cosine. Y prime double prime p. Then we got 1/2 hyperbolic cosine. Put parentheses around these things so that we have some idea. Plus 1/2 hyperbolic cosine plus 1/2 x, no, 1x hyperbolic sine 2x. Okay, and we want one of them minus 4 of this guy, none of that guy, and we want done, and when we get done we want hyperbolic cosine 2x. Alright, that's what we want. Alright, so here I've got x hyperbolic sine, and here I have x hyperbolic sine. So they go away, and here I got half a hyperbolic cosine, half a hyperbolic cosine for a whole hyperbolic cosine 2x, and the work checks. Okay. Number 10. Okay, 10, we're still doing the same thing we've been doing. So I've got y double prime plus 9y is equal to 2 cosine 3x plus 2 sine 3x. I look at the characteristic equation and I get r squared plus 9 is 0. I get r is plus or minus 3i. My y sub c is going to be cosine 3x plus sine 3x. How inconvenient. So again, my homogeneous solution has the forcing function in it. So my y sub p is going to have to be, as a minimum, ax cosine 3x plus bx sine 3x. Now if I put in a cosine x, b sine x, if I do that, they're going to cancel out because they're just part of the homogeneous solution. So I don't have to put them in my particular solution, which is good because that leaves me with more room to write. Okay, so y prime p a cosine 3x minus 3ax sine 3x plus b sine 3x plus 3bx cosine 3x. Y double prime p minus 3a sine 3x minus 3a sine 3x minus 9ax cosine 3x plus 3b cosine 3x, two more terms, plus 3b cosine 3x minus 9bx sine 3x. Isn't that just lovely? And we want one of these guys and 9 of those guys. None of these, so that's convenient. And when we get done, we want to have 2 cosine 3x plus 2 sine 3x. That's what we're looking for. Okay. So, that being the case, I have 9ax cosine. I have minus 9ax cosine. Boom, boom, they go away. I have 9bx sine. Boom, 9bx sine, they go away. Okay, so now I've got minus 6a sine 3x plus 3b, 6b, 3 and 3 is 6b, cosine 3x. Okay, that being the case, A has to be 1/3 minus 1/3. No, wrong guy. Plus 1/3. A is going to be plus 1/3, making it a 2. And wait a minute, A. I was right to begin with. My sign is positive. I need minus 1/3 for A, and B has to be plus 1/3 in order to make a 2 there. So final answer, y sub p is equal to minus 1/3 x cosine 3x and plus 1/3 x sine 3x. And it'd be nice if I had brackets up here and no 3x's, but I'm going to leave them out just the way it is. Okay, now do we think that's right? What do you think? I think so. I don't, why would I be confused? No, I don't think there's any confusion there. Okay, we'll check our work just to say we did. Checking the work. Y sub, oh, that's too hard. We're not going to check the work. 10, we're going to look in the back of the book. See what the back of the book says. And almost there. 3.5, number 10. And yeah, that's not the right answer. So why is that not the right answer? 10. Oh, that's not the right answer because we're not solving the right problem. Thank you very much, class, for telling me that. The right problem puts a 3 there. Okay, so if there's a 3 up there, then when I get down here in front of the sign guy, I need a 3, and if I have a 3 in front of the sign guy, then this is minus a half, and that's minus a half, and now that checks my backup book. So make sure you write down the right answer, right question before you get started, otherwise it might be interesting when you get to the end. That wasn't very difficult, but it was interesting anyway. Okay, so now we're going to do number 18. Now I'm pretty sure I worked this problem about 4 times before I got it right. 18. The fourth derivative minus 5, the second derivative, plus 4y is equal to e to the x minus x e to the 2x. Okay, now, so we have a characteristic equation, and it's r to the 4th minus r squared plus 4 is equal to 0. And we factor that r squared minus 4, r squared minus 1 is 0. And we get that our r's are going to be plus or minus 2 plus or minus 1. So y sub c is going to be in the form c1 e to the 2x, c2 e to the minus 2x, c3 e to the x, c for e to the minus x. Okay, and we notice that in our forcing function we have both the e to the x and a e to the 2x term in there. So that's going to make things interesting. So the first thing you would do is you would think that y sub p should be a x e to the x plus b x e to the 2x, and if you did that you would end up with the wrong answer. So then you'd say the a guy would solve, but the b guy wouldn't solve. So your second attempt should be y sub p ax e to the x plus bx e to the 2x plus c x squared e to the 2x, because I couldn't make the bx guy work. I have to throw in an x squared guy. Okay, now that I've done that, now the issue is, can I take derivatives up to 4? Do I have to go to 4? Do I have to go? Yeah, I have to go to 4 and keep my my wits about myself. So that's the other issue. So y prime p a e to the x plus a x e to the x plus b e to the 2x plus 2bx e to the 2x plus 2cx e to the 2x plus 2cx squared e to the 2x. Okay, so there's the first guy, y double prime p. Okay, so I have an a e to the x. I'm going to have another a e to the x there. So I got 2a e to the x plus ax e to the x. I have a b plus another 2 b's over here, so I'm going to have 3 b's. No, I'm going to have 2 b's here. 2 b's plus 2 b's gives me 4 b's. And so 4b e to the 2x. And then I'm going to have plus 4bx e to the 2x. Then I'm going to have plus, okay, I'm going to have a 2c e to the 2x. Then I'm going to have 4 cx's, 4 more cx's, 8 cx's e to the 2x. And then I'm going to have a plus 4cx squared e to the 2x. Okay, that's pretty nice. This is where having a bigger piece of paper helps, because that's y double prime, y triple prime p. Okay, I've got 2 plus another one makes 3a e to the x plus ax e to the x. Then I've got 4, 8. I've got 8 b's. I have 4 more b's for 12 b's e to the 2x. Then I've got 8 bx e to the 2x. Okay. Then I got 4 plus 8 c's plus 12 cx. No x. 12c e to the 2x. I have 16 plus 8 for 24 plus 24 cx squared. No, just cx's. Cx's e to the 2x. And then I've got a plus 8 c x squared e to the 2x. Okay, now we got the y fourth derivative guy of p. I'm going to change colors at this time to see if that'll help me any. Okay, so I got 3, I have 4, a e to the x. That's a positive sign. I got 24 plus 8 is 32. Oh, I forgot a term already. Plus ax e to the x plus 32 b e to the 2x. And then I'm going to have plus 16 x bx e to the 2x. Okay, I have 24 plus another 24, making 48 c e to the 2x. Then I got 48 plus 16. 48 plus 16. 64x c e to the 2x. And then I got 16 c x2 e to the 2x. Now, if I did that right, then I have a chance of getting it right. Okay, so what I'm looking for when I get done, I forgot what I'm looking for already. This is number 18. E to the x minus x e to the 2x. E to the x minus x e to the 2x is what I'm looking for. Okay, good. And going back to the original problem, I know that I want one of those guys. And I want 0 of these guys. So I'm gonna go and take one of my markers here and just put a crossy line through these guys because I'm not going to use them at all. And then I'm going to use minus 5 of those guys, and then 0 of the first derivative, and I'm going to use my crossy line thing again so I don't use it. And then I need 4 of that guy. Okay, so I got 4ax. I have minus 5ax, so that's 1ax. And then I have another ax down there. So my ax terms go away. Okay, I have 4 bx's. I have minus 20 bx's. 4 minus 20 plus 16 is going to be 0. So my bx terms go away. I got 4 cx squared. I have minus 20 cx squared from minus 16, and then I've got a plus cx squared, so my cx squared terms go away. Okay, I don't have to deal with the original problem. I only have to deal with the second and fourth derivative now. Okay. So now I've got minus 20b. Minus 20, and I have plus 32, so I've got 12b e to the 2x. 12b e to the 2x. Okay. I'm going to circle those guys so that I don't look at them again. Okay, I'm going to look at my a term. I have minus 10a, and I have 4a. I'm going to change colors. So I got minus 10 plus 4, so that's going to be a minus 6a e to the x. Okay, I've got a minus 10c, and I have a 48c. So that's going to be plus 38c e to the 2x. I'm going to circle those guys so I don't deal with them anymore. Okay, and then I got a minus 40cx. Minus 40 and a plus 64. So that's going to be a plus 24xc e to the 2x. And that gets rid of him and him. And now all the terms are accounted for. Okay, so that looks pretty nice. Now the only term with an e to the x in it is that guy. So 1 has to equal minus 6a, implying that a is minus 1 over 6. Maybe. A is minus 1 over 6. Okay. And then the term that has the e to the 2x, but there is no e to the 2x, so 0 has to be 12b plus 38c. And then I look at the x term, and I see that minus 1 has to equal 24c, implying that c is equal to minus 1 over 24. Well, c is minus 1 over 24. We can put it back in there, and we can say 0 is equal to 12b plus 38 times minus 1 over 24, and put that in our calculator, mess it around some, we get b is 19 over 144. So y sub p this is 18. Okay, so y sub p is equal to minus 1/6 e to the x plus 19 over 144 e to the 2x minus 1 over 24x e to the 2x. Okay, that looks interesting. We'll check it in the back of the book real quick, see what we think about that. And 18. Okay, so I've got a 19 over 144, I see that. If I take 6 over 124, that gives me minus 1 over 24. Okay, so that's right. And the other side is, okay, yes. So that's the same answer that's in the back of the book, only different. So checked by back of book. Okay, well that was particularly lucky that we didn't make a mistake during that one, because it has happened. Number 20. Number 20. So we're still doing the same type of thing. Y triple prime minus y is equal to e to the x plus 7. Okay, we see the characteristic equation as r cubed minus 1, and we remember that factor is 1 minus r cubed, r squared plus 2r plus 1, and that's going to give us an r that's going to give us an r of 1, and it's going to give us some imaginary numbers over here, I think. In any event, it's not going to give us, oh bummer, it did give us e to the x, didn't it? So it did give us e to the x, so we'll have to factor that into our answer. So we're going to say that y sub p is equal to some constant, they give me the constant, plus b x e to the x. If I had a c e to the x, it would just go away, and because it's part of the homogeneous solution, so I don't have to use it. Y sub p, prime sub p, the a goes away, I have b e to the x plus b x e to the x, y double prime p, 2b to the e to the x plus b x e to the x, y triple prime p, 4, what are we doing, golfing? 3b e to the x plus b x e to the x. Okay, I want 1 of him, 0 of him, 0 of him, minus 1 of him, and when I get done, I want e to the x plus 7. So that's the plan. All right, I got minus a, I got plus 3b, so there's a 3b there, and then I got, this guy goes away. So that's all I've got, 3b e to the x. All right, well, that being the case, a had better be minus 7, and b had better be 1/3. And y sub p is equal to minus 7 plus 1/3 x e to the x. Do a quick check. Y prime, maybe I can check it quicker than the back of the book can, I don't know. 1/3 e to the x plus 1/3 x e to the x, y double prime 2/3 e to the x, 1/3 x e to the x, y triple prime e to the x plus 1/3 x e to the x. I want 1 of him minus 1 of them, and when I get done I want 7 plus e to the x. Okay, well, let's see. I got 7, that's convenient. These guys go away, and I've got plus e to the x, so it checks. Now, was that quicker than looking in the back of the book? I don't know. Probably wasn't. Number 30. Y triple, no, y to the 4th derivative. Y to the 4th derivative minus 2y double prime plus y is equal to x squared cosine x. Okay, reading the instructions for number 30, it says set up the appropriate form of a particular solution, but do not determine the values of the coefficients. Okay, so that makes the problem relatively easy, I suppose. We have a characteristic equation, r to the 4th minus 2r squared plus 1 is 0. I can factor that. R squared minus 1, R squared minus 1. I can. So R is going to have a whole lot of parameters, plus or minus 1, plus or minus 1, none of which are in the forcing function, so that is really cool. So I can just write down what I need. Okay, so y sub p is going to be a cosine x plus b sine x plus d, how did d get in there? Plus dx cosine x plus d, again, I did it again. It's a c. X sine x plus e x squared cosine x plus f x squared sine x. And I'm sure that the author thinks that if we had to solve for a, b, c, d, e, and f, that we'd make a mistake in the problem and get it wrong anyway. And that's why he's asking us only to go that far with the problem. Number 32, y double prime plus 3y prime plus 2y is equal to e to the x. Well, that's a stupid looking equal sign. Okay, and we have initial conditions. Y of 0 is 0. Y prime at 0 is 3. So I get to do everything there's to do in this problem. 32. What does it say to do? 32. Solve the initial value problem. Okay, so that's what we're going to do. We're going to solve it. Okay, so I have a characteristic equation. R squared plus 3r plus 2 is 0. That factors very nicely. R plus 2, R plus 1. R is going to equal to solution set minus 1 minus 2. Y sub c is equal to c1 e to the minus 2x plus c2 e to the minus x. Okay. Y sub p is equal to a e to the x, because that's all it needs to be. Y sub p prime is a e to the x. Y sub p double prime, a e to the x. Okay, I want 2 of those. I want 3 of these. I want 1 of those. So e to the x is 6. A e to the x, clearly implying that a is equal to 1/6. So my final answer, well, it's not my final answer yet. So y is going to be y sub c plus y sub p, and it's going to be c1 e to the minus 2x plus c2 e to the minus x plus 1/6 e to the x. Okay, everything's fine there. Plus 1/6 e to the x. That's correct. Okay. So that being the case, y at 0 is 0, which is c1 plus c2 plus 1/6. Y prime x is going to be minus 2 c1 e to the minus 2x minus c2 e to the minus x plus 1/6 e to the x. Y prime at 0 is 3. Boy, that was good. I like the way the placement of that 3 went. Is 3. And that's going to be minus 2c1 minus c2 plus 1/6. So I have 2 equations, 2 unknowns. C1 plus C2 is equal to 1 over 6. No, it isn't. It's equal to minus 1 over 6. And the second one is minus C2C1 minus C2 is equal to, okay, so that would be 18, that'd be 17.6. Okay, well that looks good. I hope. 17.6. Alright, well, Kramer's rule, C1 is equal to minus 1 over 6, 17 over 6, 1 minus 1, divided by 1 minus 2, 1 minus 1. Well, let's stop. We'll do this one first. Minus 2, minus 1, plus 2 gives you a 1 on the bottom. Okay, so I've got 1, 6, minus 16, so I got 16 sixths on the bottom, which would be 8 thirds. Okay, well, if I'm 8 thirds for C1, what is C2? So C2 is going to be minus 1, 6 minus 8 thirds twice 16, 17, minus 17, 6. Okay, so if I have 2 times C1 minus C2, 2 times C1, 16. So if I have well, C1 and C2. C1 and C2 is minus 1, 6. Check. Okay, that's fine. I used this guy to solve the other way. Okay, so I hope it works the other way. Minus 2, 8 over 3 plus 17 over 6. Alright, so that's 16, square it is double it. 16 doubled is 32 over 6 with a minus sign, plus 17 over 6 is going to be 15 over 6. Don't see that. Don't see that at all. Okay, so that is, where is our error? Okay, I've got a 1, 6, and I've got a minus 17, 6. This is a minus sign. This is a minus sign. This is a plus sign. So now I've got 16 minus 1 is 15, 15 and with a plus sign, so that's 5 over 2. So, and I think that's going to work. Okay, so y sub p, no, not y sub p. What was I doing? That's coming up with C1 and C2. Okay, so final answer time. Final answer. Y of x is equal to C1 is minus 8 over 3. Minus 8 over 3 e to the minus 2x. Minus 2x plus 5 over 2 e to the x, or is it minus x? E to the minus x plus 1/6 e to the x. Okay, so we're hoping that that's right. We're going to check our work. Y prime 16 over 3 e to the minus 2x plus minus 5 over 2 e to the minus x plus 1 over 6 e to the x. Y double prime minus 32 over 3 e to the minus 2x plus 10 over 2 e to the minus x plus 1 over 6 e to the x. That's all we need, right? Okay, that's all we need. I need one of them. I need 3 of these guys, and I need 2 of those guys. When I get done, I better have e to the x, otherwise something's not right. Okay, so I've got 16 over 3. I have 16, and I have 32 over 3. Okay, so the issue is 16 plus 32, that's 48 over 3. 3 goes into 48 16 times, so that term goes away. I've got 5. I've got 10 halves. I got minus 15 halves. So I have positive 10 halves, positive 10 halves, minus 15 halves. That term doesn't look like it's going away. 10 halves, 10 halves. Wait a minute, how did I do that? This is 5 over 2. Okay, now I got 10 halves, 15 halves, minus 15 halves. That term goes away, and I got 2 plus 3 plus 1 e to the x, check. Okay, got relatively lucky. 2 more to go. 3 more to go. Alright, 3 more to go. Number 48. And number 48 we're using variation of parameters on. In fact, the next 3 we're using variation of parameters on. So we have y double prime minus 2y prime minus 8y is 3e to the minus 2x. Okay, and we have a characteristic equation. And the characteristic equation r squared minus 2r minus 8 is 0. We can factor that r minus 4r plus 2 is equal to 0. R is a solution set minus 2, 4. Y1 is going to be is going to be e to the minus 2x, and y2 is going to be e to the 4x. Okay, we need a Wronskian. The Wronskian, e to the minus 2x, minus 2 e to the minus 2x, e to the 4x, 4e to the 4x. Okay, so I got 4x, I have 4, I have minus and minus 2, so I'm going to have 6e to the 2x is my Wronskian. Okay, so y sub p, looking at page 194, okay, on page 194 where we do it, we're going to have minus y1 minus e to the minus 2x integral e to the 4x 3e to the minus 2x divided by 6 e to the 2x plus e to the 4x integral e to the minus 2x 3e to the minus 2x divided by 6e to the 2x, and this is, we're going to put a dx there and a dx here. Alright, and then we're going to have minus e to the minus 2x integral. Alright, so I've got 2x on the bottom, I have 2x on the top, I have 3, and I have 6, so this is 1/2 dx plus e to the 4x integral. I got minus 4x on the top, I've got minus 6x, so I got 1/2 e to the minus 6x dx. Right? So I end up with minus e to the minus 2x divided by 2x plus for e to the 4x over 2 e to the minus 6x over minus 6 plus some constant c. Okay, so now I've got minus e to the minus 2x over 2x minus 1 over 12 e to the minus 2x plus some constant c. Okay, final answer. Y is equal to C1 e to the minus 2x plus C2 e to the 4x minus e to the minus 2x over 2x minus e to the minus 2x over 12. We don't use the constant c, do we? No, we don't. Not going to use them. Okay, so that's what we have. We look at that and we say that's not the right answer yet. Now, why can that not be the right answer? Well, there's a e to the minus 2x here, and there's a c1 e to the minus 2x there. Those guys combine. And so my final answer, y of x, is going to equal c1 e to the minus 2x, c2 e to the 4x, minus c to the minus 2x over 2x. And if I check that, I will find out that it works. Okay, next problem. Number 50. Does 50 have a hyperbolic sign in it? Yeah, it does. Okay, number 50. Number 50. Y double prime minus 4y is equal to hyperbolic sine of 2x. I look at my equation. I have a characteristic equation. R squared minus 4 is 0. R is going to be equal to plus or minus 2. So y1 e to the minus 2x, y2 e to the 2x. And we want Wronskian. So my Wronskian e to the minus 2x, minus 2e to the minus 2x, e to the 2x, 2e to the 2x, and I'm going to have 2 plus 2 is 4, so my Wronskian is 4. I remember that sine, hyperbolic sine 2x, is e to the 2x minus e to the minus 2x over 2. And am I going to use that? I think I'm going to use that. Okay, so y sub p minus y1, e to the minus 2x, integral e to the 2x, forcing function, e to the 2x minus e to the minus 2x over 2 divided by 4, the Wronskian, plus e to the 2x, integral e to the minus 2x times the forcing function, e to the 2x minus e to the minus 2x over 2, the whole thing divided by 4. We left off the dx's again. Okay. Y sub p. Okay, so I'm going to bring out the 4, I'm going to bring out the 2, and I have minus e to the minus 2x over 8 integral. And I'm going to have e to the 4x minus 1 dx. Plus, I'm going to bring out the 2 and the 4, and I'm going to have an 8. And I'm going to have an integral 1 minus e to the minus 4x dx. Okay? So far so good. Y sub p is equal to e to the minus 2x over 8. This is e to the 4x over 4 minus x, plus e to the 2x over 8 x minus e to the minus 4x over minus 4, and we're going to do it that way. Okay, so y sub p is going to be e to the 2x over 32 plus minus e to the minus 2x over 8 x plus x e to the 2x over 8 plus e to the minus 4x over 32. Okay. Now, we look at that, and we look at it, and we see right here, it looks like we have something. This is a 2. That's a 2. That's better. Okay, so if we look at the x terms. We look at the x terms, and we see that we have a x, the x terms. Make sure I left out a minus sign, bummer. There's a minus sign there, which makes this guy minus, this guy plus. Okay, so I'm better now. Okay, that's good. I look at these guys, and I see that this is x hyperbolic cosine 2x over 4. Okay, and I look at these two guys, and I can see that they are hyperbolic sine 2x over 16. But the minus sign's in the wrong spot, so this guy is going to be a minus. So y sub p is going to be x over 4 hyperbolic cosine of 2x minus 1 over 16 hyperbolic sine 2x. Okay, that's wonderful. And my final answer, y is going to be c1 e to the minus 2x plus c2 e to the 2x minus 1 over 16 hyperbolic sine 2x plus x over 4 hyperbolic cosine. Oh, that was bad. Hyperbolic cosine 2x, and that checks my backup book. Okay, one more. Number 54. Okay, y double prime plus y is equal to cosecant squared x. Oh yeah, cosecant squared x. Why not? Okay, characteristic equation, r squared plus 1 is 0. R is going to be plus or minus I. Y1 is going to be cosine x. Y2 is going to be sine x. And the Wronskian of y1, y2 is going to be cosine minus sine, sine, cosine, which is cosine squared x plus sine squared x, also known as 1. Okay, so y sub p minus cosine x integral sine x cosecant squared x dx plus sine x integral cosine x cosecant squared x dx. These guys are over 1. I'm going to put that down. So y sub p minus cosine x integral secant x cosecant x integral cosecant x. Okay, plus dx plus sine x integral cotangent cosecant x Alright, now the front cover of your book has integral tables, and so we're going to use number 15 for him, and we're going to use number 11 for him, and we're going to get y sub p is equal to minus cosine x natural log absolute value cosecant x minus cotangent x minus 1 plus secant x times minus cosecant x. And so y sub p minus cosine x natural log absolute value cosecant x minus cotangent x plus minus 1. And 54, let me see what it says. 54 says, use the method of variation of parameter, find a particular solution. So we probably did too much work in 50. Yes, we did. All we needed was a particular solution, and we should have stopped when we did. Okay, but this is checked by back of book. And we are now done with this section.